So let's look at a few examples of using this in problems. So the thing to keep in mind, just for homework, and the general idea I want you to know is, consider it a 1D collision in the moment. So often we'll give it some more interesting physical thing happening than just that, because we're done. I mean, we've done the 3 problems. There's really nothing we can do. But for example, in your homework, there's one like this. They're sort of like always Rube. Let's see, what is it? Rube Goldberg, is that the word? Rube Goldberg? I don't know. Where you got a mass on a frictionless surface like this, and then you've got like a string and another mass like this, right? 1 and 2. And what's going to happen? Oh, it's going to swing. And we always have them set up where right when they hit, it's basically a 1D problem. Right? So we can tell you this is going to end up being an elastic collision, or an inelastic collision, really. And we could say what happens right after they hit. So what you do is you get the speed of this thing once it gets here, and then just treat it like one of these. Right? They hit. If this one weighs less, it bounces back. This one goes forward. And then once they've got their velocity from the collision, then you can do energy or kinematics again. Okay? But if you see something like curved and you think, I don't know how to do a curved collision, it's really just the 1D collision. And just at the moment, you think of it as 1D. So another example of the same thing would be like if you had a curved track, and you had a mass here, and you had a mass here. It's going to slide down. By the time it gets here, it's going to have some velocity that you could calculate. And it's just a 1D collision. Okay? So look for ways to use them. Oh, I have one more. Just while we're drawing everything we can think of off the top of our head while we're eating breakfast, is a ball comes up, and up here on the hill, there's another ball, and it's going to hit that ball. Boom. If it hits it right when it's horizontal, it's a 1D collision at that moment. And then you can do fun things like, well, if it rebounds at a different speed, it's not going to fall at the same place, right? How would you catch it? Complicated beer pong or something. So that's how you use those equations. Okay? So now the 2 fundamental ones you know one where one is still, this one is moving, and it's elastic, and you know the one where they stick together, and that's perfectly inelastic. That's the 2 we did. Okay? Okay.